Most people look up at the moon and think of it as a calm, silent, unchanging rock. Cold, still, dead. But here's something that will mess with that image forever. The moon has moonquakes. Yes, actual tremors, some strong enough to crack the surface and potentially damage future moon bases. And no, this isn't science fiction. This is real, raw, lunar science. Let's start with what a moonquake actually is. A moonquake is just like an earthquake, seismic shaking of a planetary body's crust. But unlike Earth, the moon doesn't have shifting tectonic plates or active volcanoes. So what causes the shaking? The answer is wild. Earth itself is triggering some of these moonquakes. The gravitational pull between Earth and the moon creates tidal forces. On Earth, these forces are what cause ocean tides. But the moon has no oceans. Instead, those forces squeeze and stretch the moon's body, building up stress inside its crust. And every so often, that stress gets released in the form of a moonquake. There are 4 main types of moonquakes. The first is deep moonquakes. These occur around 700 kilometers below the surface and are caused by tidal forces, basically Earth tugging at the moon over and over again until it cracks. These happen in very specific regions, and get this, they're shockingly regular, like clockwork. Scientists have even described them as happening on a monthly schedule. Imagine having scheduled earthquakes. That's the moon for you. The second type is shallow moonquakes, and these are the ones that make scientists really nervous because they're close to the surface and they can be powerful. Some of them have reached magnitudes of 5.5 on the Richter scale. To compare, that's enough to break windows and damage buildings here on Earth. On the moon, where there's no atmosphere to absorb shock waves and the ground is made of brittle rock and dust, that's potentially catastrophic. Third, we have thermal moonquakes. These happen when the moon goes from freezing cold night to boiling hot day. The temperature swing is brutal, up to 500 degrees Fahrenheit in difference. That kind of thermal stress can fracture rocks and shake the surface. It's like the moon is groaning as it stretches between extremes. And lastly, there are impact moonquakes, caused by meteoroids slamming into the moon. These are rare but dramatic. With no atmosphere to burn them up, even small rocks hit the surface hard. When something the size of a grapefruit can hit like a bullet, you understand why astronauts on future missions need to take this seriously. Now, you might be wondering, how do we even know all of this? Moonquakes aren't exactly visible from a telescope. The answer dates back to the Apollo missions. Between 1969 and 1972, astronauts placed seismometers on the lunar surface. These instruments recorded over 12,000 moonquakes. And what they found changed our understanding of the moon forever. One eerie thing stood out. Unlike earthquakes, which usually last a few seconds to a couple minutes, moonquakes can last up to 10 minutes or more. Why? Because the moon is dry, rigid, and doesn't have water to help dissipate the energy. It just rings like a bell, literally. Some seismologists say it's like the moon is hollow, or at least extremely resonant. That's creepy, right? And here's where things get even more interesting. In 2019, data from NASA's Lunar Reconnaissance Orbiter showed that the moon is still shrinking. It's cooling down, which makes the crust contract and crack, kind of like the skin of a grape drying into a raisin. These cracks, called thrust faults, are pushing parts of the crust over one another, and that too causes quakes. So now, let's put this in perspective. Imagine being an astronaut in a future moon base, just finished a long day of collecting samples, and suddenly, boom, a shallow moonquake hits. Your habitat rattles. The regolith outside shifts. There's no weather on the moon, but now you have to deal with tectonic tantrums from a celestial body we once thought was dead. The moon might not have oceans, rain, or breathable air, but it has motion. It has drama, and it has a pulse. And maybe that's the biggest takeaway. Space is not silent. The more we learn, the more we realize these distant places are dynamic, alive in their own alien ways. And as we get ready to send humans back to the moon, moonquakes aren't just fascinating trivia. They're a safety hazard we have to engineer around. Because the next great leap for mankind won't happen on still ground. It'll happen on a trembling, unpredictable lunar surface. Don't forget to like, comment, share, and subscribe for more videos. Until next time.